Okay, this video is on first normal form, second normal form. By the way, I don't know if I've noted this anywhere yet. I might have on the whiteboard in class a couple of times, but the abbreviated way of referring to these in writing is like this. That's first normal form, second normal form. Occasionally, you will hear people when they're talking about this stuff say 1NF, 2NF. I usually just say it. First normal form, second normal form. But if I do write it, I probably will write it like this. So 3NF, BCNF is Boyce-Codd normal form, and of course 4NF. I hardly ever see that one actually, but it has to exist. Anyway, you get the idea. So second normal form is what we're talking about. Let me first say this. You will not have if your database is in first normal form and it has one attribute as the primary key. It's not a combined. Like, for instance, the one we have now is a combination of project number and employee number. That means it may or may not be in second normal form because of the fact that it has a composite primary key. If it is in first normal form and it doesn't have a composite primary key, then it is already also in second normal form. So, starting over kind of. If you're in first normal, a database table that is in second normal form is in first normal form, and that's true for all of these. Third normal form, I think I said this already, but third normal form is in first normal form, second normal form, and some other stuff. So the and other stuff for second normal form, first normal form plus no partial dependencies. So let's describe what that is. So these dependency diagrams are sort of showing how this behaves. A functional dependency in a database table means that the value of one of your attributes, one of your old bubbles, your column heading, however you want to think of it, can be determined by some other bubble or some other column in the same row. So it's best to just show an example. If you know the employee number, then you do know the employee name. Because employee number 217 is Clark Jefferson, for instance. If you know that 217, you know for sure what the name is. Now, it doesn't work the other way necessarily, right? Because if you know John Smith, do you know what the employee number is? Maybe not. There could be 10 employee numbers that have John Smith as the value for the employee name. So the direction matters. In the case that we have here, all these things that have arrows pointing to them are functionally dependent on something else, at least one other thing in the database. It could be more than one. So that's what a functional dependency is. These lines are showing how things are dependent on each other in this particular database, this first normal form database that we created, table that we created. It has two primary keys. If you know the project number, you know the employee number, both. If you know both of those things, then you know the exact values of all the blue things, basically. We'll put it that way. The gold things together guarantee that you know the values of all the blue things. But there's kind of an issue with that because it's also true that if you know just the employee number, you know the employee name. It has nothing to do necessarily with the project number. If you know the employee number, you also know the job class. If you know the employee number, you know the charge per hour. If you know the project number, you know the project name. The only thing that's in this whole table right now that's dependent on both at the same time is the employee number and project number. Both together determine the hours. Well, what does that mean? Let me show you an exact example. So if you know 15 and you know 103, then you know 23 hours. Because what you're saying is that on the Evergreen project, June worked 23.8 hours. If you know, I know she's in here more than once, isn't she? Maybe not. So let me use a different example. I hate this. So if you know 15 and 101, you know 19.4 hours. You know that John G. News worked 19.4 hours on the Evergreen project. If you know 101 and 25, then you know 56.3, because what you're saying is that you know that John G. News worked, how much? 56.3 hours on the Starflight project. You have to know both in order to know this. You don't have to know 25 and 101 to know John G. News, right? All you need to know is 101, 101, 101, John G. News. If you know 101, you also know database designer, right? 101, database designer. If you know 101, you know 105 per hour, right? So you don't need to know both. These are called partial dependencies. And they can also cause it, I don't want to go into all anomalies, but let's say if you delete both projects that John G. News is on, then you lose all information about John G. News. How much he makes per hour. Obviously, you know, if you delete the project, you don't need to retain 19.4 because for whatever reason you don't care about 15 Evergreen project anymore. But you could, if you delete 15 and 25 both, then you lose all your information about John G. News. That might not be good because he might be needed to work on other projects. Anyway, the update and the insertion also, you know, matter. You'd have to create a new project for him if you have to have the two things together to make a primary key. I think I talked about that last time. So let's look at the solution. I think we want to see the solution is something called decomposition. So composition, the etymology is position together. Com means together, position put. You put things together. Decomposition is to take them apart. Reverse that process. So we're going to take this one first normal form table and break it down into several tables. And kind of with this example, you have to show more than one thing at a time because we need to retain all this data, right? And the way we do that and still preserve second normal form is this way. Create a table for the project for this primary key because there's partial dependencies. If there are partial dependencies, then you need to create a table for that key alone. Same with employee number. This thing, and this thing all depend on that alone, not the project. So we make a table for the employee. So project, employee, and then you just put the things in that table that are associated with that particular thing. So the project number determines the project name. It makes its own table that way. The employee number determines the employee name, the job class, and the charge per hour. If you know this, you know the values for all these other things. So make a table for it. So this one table's been broken into two, but you need to know both the project number and the employee number to know how many hours they worked on a project, as we saw before. Because the assigned hours, the amount of hours they worked on the project, depends on knowing both those keys. So we need a third table for that. So all these tables are in second normal form because this is first normal form. It has a primary key. All these are single values. And there is no combo key. There's no combined, what's the word for it? I just said it a million times. Composite. There's putting together, right? You put two keys together, composite, and you have one key. So there aren't two. So if it's in first normal form and it's only got one key, one value for the key, one attribute as the key, I should say it that way, then it's automatically in second normal form. So this is in second normal form, first and second. This is in first and second, and this is also in first and second because the only thing that's not a key in this whole table is functionally dependent on the combined values of the entire key. And again, that is key, so to speak, for understanding second normal form. These are kind of go without saying. Like I said, if it's first normal form and it just has one thing for the key, it's automatically second normal form. But if it does have a composite, you have to check and make sure that everything is blue over here. There could be more than one thing. This one only has one. You have to make sure that this thing you can only figure out what the value it goes inside of it is. Only if you know the values of both the parts of the key. If that's true, then it's also in second normal form.